Okay, so take the time to read the question and make sure that you start getting a feel for it. If you want to have a go, then what you do is you pose the question first, and then you then listen to the solutions. So the first thing that I do in mechanics or in maths in general when I read such a wordy question is I'm going to start by drawing a diagram. So what do we have here? A car that pulls a trailer. So I'm going to draw a trailer and I'm going to draw a car. So I'm going to have my trailer here and then I'm going to have a car. I draw them with quite a distance between them because I know there's going to be some forces between the car and the trailer and I want space. So I'm going to just connect them, and of course I'm not going to bother drawing little cars. That will just be fine. That's going to be my road. Using my toolbar parallel to the road, and the next step is going to be drawing all of my forces, and to make sure that I don't get confused, I choose to change color for that. So which forces do I have? I'm going to start by drawing the one that they are mentioning. So there are some horizontal resistance which have magnitude 600 and 200. That's for the car and the trailer. So I'm going to draw them. I'm going to assume that the car is going forward, so I'm going to assume the direction is that way. So I'm also going to assume that the acceleration, I'll draw it afterwards. So resistance to motion, this is my resistance here for the car. So this is the 400 Newton, and then there's resistance to the trailer as well, which is a bit smaller. It's probably a smaller trailer, or it's a bit protected by the car in terms of wind. Anyway, they tell us it's 200 newtons. What else? The engine of the car produces a constant horizontal force, so that's going forward, and it must be quite a big force, otherwise the car and the trailers are not going to move. So this is 1200. 1200. So I've done this to 400, 200, 1200. Find the acceleration of the car and the trailer. I've started doing forces, but I'm missing a lot. I would systematically draw all of the forces, which means I would also draw the gravitational force, which on the trailer is 200 G, and it's touching the road, so the road is going to be reacted as well. So I'm going to have a first reaction here. There is a gravitational force going down here, which is going to be 800 G, and then the reaction of the car at that point. Now some teachers, some people say, why do you bother? They are not going to come into play. It's just a habit I have. I'm just always drawing all the forces. And then there's forces between the trailer and the car, because if the trailer is pulled by the car, then there's a force that goes forward. So that's really the pull force. I'm going to call it as a tension. It's going to pull it forward. And then if the car is pulling the trailer, so the trailer feels the force forward, so the car is feeling the force backward. Opposite direction equals in forces. So I've got a tension here. Do I have all the forces here? Yes, I have all the forces. Acceleration. So I'm going to need to calculate the acceleration. So for this, I'm going to need to project all the forces. I'm going to need to resolve the forces. So I'm going to assume most likely that the acceleration is going to the right, and I'm going to take that as the positive direction, and I'm going to start. So for the trailer, I'm going to choose positive direction are going right, and the forces is minus 200, so the resistance is against motion. Then we have the tension is what's causing the motion, equals 200 A, and so some of the forces, so that's my second law, so Newton law, sum of the forces equals ma. Then I'm going to do the same for the car. The positive direction will be the same, and I still have the resistance, but this time the tension is going against in the opposite direction to the acceleration, and we have got the engine force. So we've got the plus 1200 newtons equals what we have here was the mass of the car, 800 A. So once I've done my forces, I need to calculate the acceleration. I'm going to add the two of them together, so that gives me minus 600, the t's cancel, plus 1200 equals 1000. No, not yes, 1000 A. So that gives me 600 equals 1000 A. So that's, I can cancel by 100. So that gives me A is 6 over 10, so 0.6 meter per second squared. And that's going to be your first 3 marks. And then the second one, well, once we have done that, it's quite straightforward. I've got the acceleration, so I take one of the two equations. I'm going to take equation 1 because it's simpler. So I've got minus 200 plus t equals 200a. So t is going to be 200a plus 200. And we know that a is 0.6, so it's 200 times 0.6 plus 200. I've got a calculator near me, so that's 200 times 0.6, and I'm going to add another 200, and that gives me 320. So my tension is 320, and newtons. Always make sure to put the units. And that's 6 marks in the bag already. So that's quite a lot of marks. So remember, you just write your equations using your Newton's law, and then you simplify. And now we'll try the third part of this question. What's happening here? The driver sees a hazard. So what does it mean? Reduces the forces produced on the engine to 0. So basically he lets go of the accelerator. So that force here is gone, and he starts braking. So the brakes produce a force on the car of magnitude F, and the car decelerates. So we no longer have an acceleration going forward. The acceleration now is going backward. The car is decelerating, and there is a braking force. Sorry, there's a braking force going to the left. So what does it mean in terms of all of the forces if we go around? Mass and reaction, they are irrelevant anyway, but what was I saying? So the mass and the reaction are irrelevant, but they wouldn't be changed anyway. You're told that now the resistance are unchanged, so the 400 and 200 stay here, but of course the interaction in the tow bar is going to change. And what you need to think about, so that's the braking force, by the way, so that's the force here. It's telling you now that the magnitude of the thrust in the tow bar is 100. Yes, but the biggest thing that's happening in the tow bar is now the trailer is moving quite fast. The car is decelerating. So think about what the trailer is doing to the car. So the car is going slower, and the trailer is still arriving with a smaller speed, if you want. So it's actually going to try to oppose this braking action. So this time, what's happening is that the car is not pulling the trailer. The car is trying to slow it down. Okay? So very important change here. Now, the car is not pulling. The car is trying to stop the trailer. So what's the trailer doing to the car? Well, the trailer is still arriving with lots of speed. So the trailer is not slowing down the car, is not against all these forces. The trailer is actually pushing the car forward that's trying to brake. It makes the braking harder because of this. It's like, imagine you're standing somewhere, you're walking and you're trying to slow down, and someone behind you is still pushing. Then you feel this force in your back. You feel the person says, stop pushing, I'm trying to stop here. It's the same thing. And that's the change that you have. So how am I going to find this thrust? Well, we are told that this thrust here is 100. So we're going to need to look at the second law of motion. Do I know what the acceleration is? No, I don't. So I'm going to look at the trailer. And I could change direction, but whatever. Well, I'm going to change direction as well, so this time. So I'm going to go and say my positive direction now is the direction of the acceleration. You don't have to. But what forces do I have? I've got the trailer, which is 200, and I've got this thrust, so the car trying to slow me down, which is a 100. And that gives me my MA. So M is, I forgot now, yes, it was 200. A, which is a deceleration. Do I know what A is? No, I don't. So if I go to the car, I'm going to choose the same. What forces do I have? I have a braking force, which goes the direction I've chosen as positive. I have got the resistance, which I had from the beginning. And this time, I also have this thrust. The trailer is pushing me forward. So this force here of minus 100 equals 800 A. What am I looking for? I'm looking for F. I've got two unknown. I can use my first equation to work out the acceleration. So 200A equals 300 divided by 100. So that gives me A equals 3 over 2 is 1.5. And then finally for the second equation, now I know that A is 1.5, so I've got F plus 300 equals 800 times 1.5. So this braking force is going to be 800 times 1.5 minus 300. So 800 times 1.5 is 1200 minus 300 is 900. And don't forget the unit newtons. So it's actually not that much work for 7 marks, but the difficulty here is to understand well what happens in terms of forces, and especially to understand what's happening in this bar. So try to think, when you do this sort of question, try to think about your knowledge of real life, because you do know that if you're going forward and you're pulling something and suddenly you try to brake, then whatever you're pulling or whatever is behind you attached to you is going to try to push you forward. While you brake, you've got a bigger job to brake, and that's how you finish this question.